as we saw in class, if I compress this, the volume decreases, the pressure increases. I release it, pressure goes back to where it was. Almost seems like there's a leak. That thing should pop back a little better than it did. If I was to heat this, now my hands aren't all that warm, it's not going to heat it that much, but it will increase the pressure without changing the volume. If I was to blow into this thing somehow with a valve and a tube, or like pumping up a tire, if I take an air compressor and get air to go in here, I can increase the pressure without significantly affecting the volume, at least until we get up to about 13 atmospheres. The bottle will burst. But these bottles are really tough. It takes a lot of air to do that. Now, when we talk about these things, we're actually talking about variables that we'll call N, P, V, and T. N for the number of moles of gas, P for the absolute pressure relative to the pressure you would have at absolute zero, volume, obvious, and T the temperature. Again, absolute temperature, not Fahrenheit or Celsius, temperature relative to absolute zero. All other things being equal, by all other things, these are the four things. Okay, less V, more P. Implicitly then, N and T would be equal. They would be constant. They would be the same. If we keep N and T constant, less volume, more pressure. How do we keep N and T constant? We compress this thing with something at room temperature. Maybe I cool my fingers and I compress this. And by sealing, I keep N constant. We get no more or less moles of air in there. More temperature, more P. How do we do that? Well, that was just, we heat this thing up somehow. Again, N is going to be constant because the bottle is sealed. Volume is constant because this thing is not going to expand appreciably. Okay, more temperature, more volume. Well, doesn't that contradict this? No, it doesn't. In this case, we're keeping N and P constant. And that would correspond to, let's say, for example, I loosen the cap so that when I heat the gas up, some gas escapes. The gas inside expands and drives some of the gas that was originally inside out, so that we have more volume. Now, if we put a weak balloon over this thing, the volume could expand into that balloon, and you'd be able to see how the volume increases. More N, more P. If I somehow get more air into this, which I could easily do with a valve, a hole through the top, and a pressure tank or a compressor, I could get more air in here. What would that do? That would increase the pressure. It would make it a lot harder to compress this thing. Okay, so these are all fairly familiar and fairly easy situations to understand. You want to concentrate on the fact that there are four variables. If we control for two of them, the other two are going to vary in these ways. And you can think of if there are other possible pairs of variables. Actually, there are four variables. There are six possible pairs. Which two did I leave off? What kind of a situation would correspond to the two that I haven't mentioned here?